Hello to all of you and welcome to this webinar. I am Filippo, the application engineer. I'm here with my colleague Simone, and today we will see together how to acquire a model with implants. We will acquire the model with the DSEX Pro, and then we will acquire the same model with our oral scan. Then I will pass the microphone to Simone and he will show you a mesh comparison between the surface that we acquired with the desktop scanner and the intraoral scanner in order to study together these meshes, and finally I'll import the surface, the mesh in exocad in order to proceed with the restoration. I would remember to write all your questions in the chat. At the end of the webinar, Simone, Riccardo, Rita and I will answer you directly. Let's start defining the job in exocad. As I told you, we will acquire a model with two implants. The first implant is in the element 25 and the other one is in the element 27. Okay, implant based. And about the gingiva, yes, I would to scan separately the gingiva because with the new software release of the desktop scanner is possible to obtain the auto extraction of the gingiva. Then neighbors. Then we are ready to save and scan. Okay. Okay. I have just placed the model on the acquisition plate. As you can see, we have a gum in wax, but with the blue light scanner it's possible to acquire perfectly also the wax. Okay. Let me check the surface. It's perfect. We can press next and proceed with the acquisition of the scan bodies. I've just screwed the scan bodies. Okay, start with the acquisition. I would remember you that when you have some metal parts, it's necessary to use the scan spray, especially on the implants, in order to have a perfect surface. Perfect. Let me check also this mesh. Okay, next. Now the software is matching the two surfaces that you acquired, the surface with the gum and the surface with the scan bodies. As you can see, the match is complete. Let me check. It's perfect. Pressing complete, the acquisition process is done. As I told you before, now I would like to set the same job with the oral scan, with the intraoral scanner. I did a time lapse related to the acquisition because I would like to pass the STL to Simone in order to study the differences between the two surfaces. Okay, this is a short time lapse that I did during the morning. Now you can see better the model that we acquired also with the desktop scanner. This is the case, and now I'm acquiring the model with the scan bodies. As you can see, the workflow is the same for the desktop scanner and the intraoral scanner. Okay, here you are the model with and without the texture information, and placing the model in the right position for exocad, we are ready to pass the microphone to my colleague Simone.
Hello everyone and welcome to this live session. My name is Simone. and I work as an application engineer in the European team of Shanghai. I'm going to show you the comparison between the surfaces acquired by my colleague Filippo. On the screen, you can see the mesh acquired with the desktop scanner. On the left side, the surface acquired by the intraoral scanner, and between them, the surface of the digital scan body imported from the implant lab. So, what I'm going to do? For performing this comparison, I will define the implant axis for both the acquisitions. Then I will check any eventual deviation in the implant direction and also in the implant height between the desktop and the intraoral acquisition. So let's start registering the positions of the two acquired meshes. Okay, I'm working with a mesh editing tool. So, the registration process passes through two different steps. Manual one, where you are asked to define which surface can be considered as fixed and which one can be considered as floating. Then it's necessary to pick 3 points on the fixed mesh and more or less the same 3 points on the floating. 1, 2, and 3. This is the result of my manual registration. That is terrible. But it's possible to refine this result thanks to the global registration. So in the global registration, the software is asked to move the floating mesh in order to achieve the best fitting between the two meshes. It's also in the most common mesh editing tools. Also, a color map is available at the end of the global registration for checking if this process has been performed properly or not. When you see green, means that it's okay. Done. Apply. So now I have the two acquisition meshes were registered between them. I will repeat the same process between considering the digital surface of the scan body and the desktop acquisition. So I will move, thanks to the registration process, I will move the digital surface of the scan body on the desktop acquisition. The same steps as before. So fixed mesh, floating mesh, pick 3 points on the fixed, pick more or less the same 3 points on the floating. Don't mind a lot about the final result because now the two meshes are close enough for allowing the tool to move. Oops, I did not save, sorry, that is my fault. Without saving, it's so complicated to get the final result. So let me repeat, 1, 2, and 3. Let me rotate it. 1, 2, and 3. And apply. Global registration, the fixed mesh is the acquisition. Run, the software is moving the floating for achieving the best fitting, and the final color map. It's green, means that it's okay. What I have now? I have the desktop acquisition and the well-positioned digital surface of the scan body. On this digital surface, I would like to define the cylinder, a geometrical cylinder, for getting the implant axis. For doing that, I have to that there are different way for getting this result. My way is to delete what I don't need, like in this case, to create a cylinder, a geometrical cylinder, starting from the highlighted surface. There we are, and that's it. This is the cylinder. Once defined the cylinder, I have the possibility to create or to define the axis, its axis. That is the implant direction. Okay, what I'm going to do now, I want to repeat exactly the same procedure, but for the internal acquisition. So this is the final result of the internal acquisition. Okay, let me import another digital surface of the scan body and let me repeat exactly the same procedure. So manual registration, 3 points. As before, I'm focusing on the scan body position, 1, 2, and 3. Save, just for avoiding the mistake I did before. Global registration for refining the registration of the digital surface of the scan body on the intraoral position, and the final color map for checking if everything is okay. Okay, perfect. Now I have the intraoral acquisition and the digital surface, the digital surface of the scan body. This one. There we are, perfectly let's say registered, so in the right position. But the master, the reference, is the intraoral acquisition now, not the desktop as before. So I'm going to define the cylinder as I did before, deleting what I don't need, highlighting the mesh that will fit and apply. Now I have defined two different cylinders. Let me hide, I did not do before. This is the second one, so the cylinder defined on the intraoral acquisition, let me say this way. So I can define here a new axis and I can get visible, and let me call it this way, desktop and intraoral, also for the axis for comparing them. So let's compare the two axes. Hide. This is the axis, the implant axis defined on the desktop acquisition. So the surface acquired by the desktop scan. That actually is my colleague Filippo is working with the SAX Pro S hardware version provided by Shanti. And this is the axis defined, implant axis defined on the surface acquired by the intraoral scanner. So the our scanner provided by Shanti itself. Let me show both of them, and they are exactly on the same position, so exactly the same direction. This is very, very, very important. Second, let me check all the values. This is the cylinder defined on the desktop surface. I can export some details about it. Let me exporting this one. Okay, so what kind of details I've just exported? The base center coordinates, the axis direction, the radius and the height of the cylinder. This is done. Let me hide this one and let me show just hide both, hide everything, and let me show you just the interval, the cylinder defined on the interval. As before entity, I would like to export this data. Okay, let me rename it. Okay, here we are. This is the final result. So I exported the details about the cylinder defined on the desktop acquisition and the cylinder defined on the intraoral acquisition. I have the same details in general, so the base center's coordinates, the axis direction, the radius, and the height. And let's check together how is this result. Is from my side very good. You can see some differences between the base center's coordinates, the axis direction, also the radius, also the height. But remember that the unit of length is the millimeter, so we are facing deviations that are less than 1 micron. In view of all these, I can confirm that there are no substantial differences or deviations in working with the desktop scanner or the intraoral scanner provided by Shining 2D for an implant job. Thanks a lot for your time. From my side, that's it. Thanks a lot for your attention, and I hope this part of the live session can be helpful for you for understanding deeply how to define implant axis and so on. Actually, in case you work with exocad, at the first step, exocad is asked to do exactly what I did during this presentation. So thanks again and take care. Bye.
Thanks a lot, Simone, for this incredible and very interesting presentation. Okay, we can proceed with the restoration pressing the design button. Here you are the STL that exocad import completely and automatically, as you know. We need just to press next in order to tell the software that the orientation of the mesh is correct. Now I'm selecting the correct implant library in order to match perfectly the mathematical surface of the implants with the scan body that we acquired. Pressing next, exocad get the best fit between the mathematical surface and what we acquired. Okay, now we are ready to design the margin where we want to have the base of the implant in contact with the gum, or with a specific value, with a specific distance that we will set later. Okay, the same for the element 27. It's exactly the same of a margin ring. You can detect it, or if you prefer, you can draw it. I prefer draw it. Let me fix the points. Okay. Proceeding in the exocad workflow, now we are ready to set the library that we want. I suggest to use in the model, in the mouth where you have the teeth in the opposite position, the mirror tool is very useful and is very comfortable in my opinion. As you can see, it's just necessary click before on the element that we want to copy, and then we need to tell to exocad which number of teeth we copied. Okay, that's it. Let me try to find a correct position, or better, a good position for these teeth. I would tell you in advance that I'm not a dental technician, sorry, and for sure my modellation, it will be very bad and not so beautiful, but I would like just to tell you some tools, useful tools that you can use for the future restorations. Okay, the position now should be okay. Let me try to fix the element 26 because it's exactly in the middle where we will have the hole for the implant screw. We can proceed. For sure all of you know better than me all the tools that we have in order to check and to modify the lower part of the implant. For this reason we can press next. Okay, here we are in the more interesting part, and this is the part where I want to share with you some information. The trick that I would tell you is that if you use the mirror tool in the position step, here is very comfortable in my opinion to use the adapt to gingiva. Inserting a negative value, you can obtain the shape that you are seeing in the monitor. The tooth go under the gum, and with the sculpt tool you can adapt perfectly, you can design perfectly, removing the material as I'm doing the lower part. Okay, once again it's just an example, but the important thing is to understand or to know the tricks and the tools that we have. Let me enable the visualization of the elements 25 and 27, and here I would share with you another useful tool. Especially it's useful especially when you use the mirror like we did before. As you can see, selecting the paint moving parts is possible to select the parts that we want to modify, and especially in this restoration the part that I'm selecting is the part that we want through the gum. It's the part that we want to stretch under the gum. Okay, as I'm doing now, I selected the pull moving parts with the mouse, and I'm stretching that part under the gum, as exactly the same as before, exactly as I did before. Now I'm removing the material that exceed under the gingiva. Okay, once to remove all the material under the gum, you're able to proceed. And once again, I think this is a nice trick, a useful trick that you can use, especially when it's possible to use the mirror. Okay, let me try to complete this restoration. Once again, sorry for the shape. I know that is not so beautiful. Okay, I think it can work. Okay, I'm proceeding Here we are in the connector, and finally in the step related the screw channel. Here you are the bridge that we designed together, that we complete together, and we are ready to mill or to print it. Thank you for your time, thank you for your attention, and if you have any question, please feel free to ask us what you prefer. We are completely at your disposal. See you in the next webinar, and thank you once again.